All right, it's not showing up. That's not good. Okay. Actually, what a time for an update. All right. Welcome back. Everyone have a nice week. Wonderful. All right. 10 minutes late, even though I was here early. Well, we'll dive right into it. Happy St. Patrick's Day and happy review of Triggs. So I mentioned before we left that I would post the homework assignment, and then looking at what was available to me, you wouldn't have really had any luck doing any of it because there really wasn't anything I could assign that only involved sine, cosine, and tangent. So hopefully you enjoyed the week off. I know every one of you emailed me and were like, well, what about the homework? No one did. It's all good. But we're back on track. All right. So with no further ado, let's just kind of get our mindset back. Right triangles. Something like that. Put this on quiet here for a minute. All right. What's the relationship between A, B, and C in a right triangle? If it's C is the hypotenuse? A squared plus B squared equals C squared. All right. So lowercase letters represent sides, and these are three sides of a triangle. C is the hypotenuse. A squared plus B squared equals C squared, called the Pythagorean theorem. I mentioned like we would call this maybe capital A, capital B, and capital C. That represents the angle measures. Cool. What else did we talk about? What side is opposite B? Lowercase b. All right, good. What side is adjacent to B? Little a, all right? So C is the hypotenuse. Just remember what opposite, adjacent, and hypotenuse are from an angle. All good. We talked about this thing. Capital S stands for the sine, not sin, but sine, good. It's a ratio of opposite to hypotenuse. Capital C is, which stands for adjacent to hypotenuse. It's literally a ratio, that's it. And tangent is opposite to adjacent. Last thing that we should be working, I think we talked about the 45-45 and the 30-60-90 triangle. Yay or nay? Yay. I think I said, imagine like an equilateral triangle. Oops, that wouldn't be 2 there. Undo that. This would be half of it. This would be root 3 of it. If this was 1, 1, this would be root 2. Even if these weren't the numbers, I'll slow down right here. You definitely want to know these two triangles. So 30, 60, 90 triangle. Opposite the 30 is the smallest number here, 1. And although this looks like the biggest number, it's not the number 3. It's not 1, 2, 3. It's the square root of 3, which, well, it has to be less than 2 because the square root of 4 is bigger. Square root of 4 is 2. This is something smaller than the square root of 4, so it has to be less than 2. So the biggest number here is actually 2, which is opposite the biggest angle. And then opposite the middle angle is this middle value, square root of 3, which, if you want to know what it is as a decimal, pick up a calculator, but we actually want that number, square root of 3. Know that triangle, know how to set it up in different orientations. That means if I was like, hey, the right angle is over here, and this is your 30. No matter how that triangle is drawn, you should be able to say smallest angle, opposite it is the smallest side. Biggest angle, opposite it is the biggest side. And that's going to be root 3. What's up?
Is that third side always the other side's added together and squared, or is it?
Well, there's a few things going on here. First, in any right triangle, 1 squared plus 3 squared is going to make that number squared. That's a Pythagorean theorem. This is a very specific right triangle. It's a 30, 60, 90 right triangle. I don't know if I'm answering your question.
Just in both of those triangles, you add 1 and 1, and the third side is 2 squared. So if you add the other two numbers on the other one, and the squaring, it's 3 squared.
Are you referring to both of these triangles?
Yes.
So 1 squared plus 1 squared has to be this number squared. So 1 squared is 1, 1 squared is 1, 1 and 1 is 2, and the square root of 2 squared is 2. So, yep, that's true. Now, in this triangle, we have 1, we have a root 3, and we have a 2. And that's also going to be true.
Yeah, you just answered my question.
Okay. Cool. All right, good. I just want to be careful, like these two numbers are not the same numbers. They both have a 2 somehow in them, but that literally is 2, and that's the square root of 2. All right, so back on track here. Know how to set up any 30, 60, 90 triangle. And that's something that should be memorized. So I'll say it again. Opposite 30 is your smallest number 1. Opposite your largest is 2. And then the middle one is 3. And I would just say it's like easy as 1, 2, 3. For 45, 90s, these two angles are the same. So the sides opposite them are the same. And just know the fact that that was root 2. So I know that's in the video because I kind of rewatched the video myself just to remind myself where we left off. And those were the big ideas that we went over last class. We also, I guess I'll just dive right into it because we're already behind. So kind of wrapping up this right triangle stuff. Angles of elevation and depression, two commonly referred to vocab words or phrases that I think are like trigger phrases. So when I read them or I hear them, I instantly think I need to draw a picture. So when a question states blah, 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 angle of elevation, you're immediately going to think of, I need a right triangle. And this angle right here, it literally has to be in that position is your angle of elevation. So we did something like this last time. I mentioned something like a tree. Bless you. You might want to measure how tall a tree is. That's supposed to be a tree. And I remember saying, like in high school, we have, well, you can even do this yourself, download a inclinometer, which allows you to measure angles. But here's the idea. If I'm looking straight ahead, which I am right now, I have no angle with my eyes. I'm just literally zero angles. And then if I look straight up like that, that would be a 90-degree angle of elevation because I rotated my head directly upwards, right? So 90 degrees. So if I slow motion that, I'm at 0. Well, then I might stop right here and say, ooh, that's like a 10-degree angle of elevation. Long story short, I imagine it looking straight across is 0. And then as you look up at something, that's your angle of elevation, whether it's the top of a building, top of a tree, or whatnot, right? So there's your angle of elevation. Angle of depression. Actually is right there. And the way that makes sense to me is if I was in a tree, so very similar. Or maybe I'm like in a watchtower. So I'll try to build a watchtower up here. All right. And here I am watching for wildfires, since there seems to be a lot of wildfires going on right now. So if I look straight out ahead, I'm looking in space, but I'm just looking in the air. Now, I'm not going to look for fires up there. I'm going to look downwards and try to spot fires in my watchtower. So looking straight ahead, there's no angle of depression. There's no angle of elevation. There's nothing. You're looking straight ahead, just like looking straight ahead here. If you look upwards, you have an angle of elevation. But if I'm looking downwards and I spot a wildfire, call 911. Actually, I am 911. I have to call the dispatch to tell them where it is. Well, that angle right there is your angle of depression. Most important thing to remember is that the angle of depression, the angle of elevation, is always made with the horizontal. That means here's the horizontal, looking straight out, and then looking upwards is the angle of elevation. If you're in a helicopter in a watchtower on the top of a cliff, you're looking straight out. There's no angle of depression until you look downwards. But see, both of those angles are made with the horizontal. All right. So again, we did something similar to this last time, but now I'm just incorporating the vocab. A building casts a 72-foot shadow on the ground when the angle of elevation of the sun is 40 degrees. How tall is this building to the nearest tenth is the goal. So as I said earlier, I consider it like a trigger phrase. It's like I see that, boom, draw a picture. Not with a highlighter, though. Shadows live on the ground. Here's the building. Here's the angle of elevation with the sun. Furthermore, we know that this is 40 degrees. How tall is the building? Let's call it X, since that's where the building is. By the way, little side note, if you were thinking that's the building, unless it's the Leaning Tower of Pisa, I don't know what building is leaning like that. So your building is going to be straight up and down with the ground. All right, now I can kind of maybe just put a little speed to this, or reminder. This was kind of like the only other thing we did in addition to those review topics before, except for the word angle of elevation. We used calculators and trig ratios to solve this. I know information about angle 40. With respect, or from this perspective of 40, X is the opposite. That's opposite 40, right? And this 72 is the adjacent to 40. So which ratio do I want to use? Well, the one that compares opposite and adjacent, since that's the information I have, known as the tangent. So sine r, we're going to say the tangent of 40 degrees is opposite over adjacent. And now we're moving. As scary as this looks, we're simply going to do what to both sides? Multiply both sides by 72. So you get 72 tangent of 40 degrees is X. And it's only at this point, only once you have your variable isolated, should you start, or not even start, should be the first time you pick up your calculator, right? So 72 tangent of 40, and you'll get a value, hopefully, of about 60.415, blah, blah, blah. If you're not getting that, you're probably in radian measure. We had someone have that last time. If you don't know what that means, you will after tonight or after this evening, right? Anyone using a calculator and not getting 60.4? So X is about 60.4, and the label here was feet. Just reminding us that is literally an approximation. If something asks you for an exact form, that's what it's referring to. There's literally, this is the exact answer. It's kind of meaningless, right? Like if you actually want to know something, it's like, what? Well, what does that mean? But that is the exact answer. And I'll let that go, all right? Questions, comments, concerns? the good old top of an apartment building. Because you know it's so important in the real world to measure the angle to where a car is parked below. We've all done that. I don't know how many times in our life. All right, so from the top of an apartment building, there's an angle of depression. Key phrase, trigger phrase, draw a picture, obviously. But let me read through this. To a car parked on the street, parked on the street below, that is 38 degrees. The car is parked at 80 feet from the base of the building, and find the height of the apartment building. Okay, so draw a picture. Now again, if I was a stick figure, that would be me. And if I look straight ahead, that would be 0 degrees. No angle of elevation, no angle of depression. When I look down, when I look this way, there's my angle of depression, which is 38 degrees. Here's the car, broom, broom, which is parked 80 feet from the base of the building. So again, this is not 80. We're not connecting like a wire to the car. That would be 80 feet. This is the building. I'm on the top of it. This is the base of the building, 80 feet from there. And once again, we want to know the height of this. So what are you guys thinking? Yeah. Cool. Super warm. A little bit off there, but you had the right idea. The number one incorrect answer is a lot of students will use this 38 and say like, oh, that's opposite and that's adjacent. No, it's not in the triangle. All right. So that's the biggest thing to notice is 38 is not at all in this triangle. We need to be inside the triangle. And the idea is, okay, you said 180, but I know what you meant. What's this angle right here? 90 degrees. If part of it is 38, how might I find the other part of it? Subtract. 90 minus the part we have gives us the remaining part, 52 degrees, okay? Now this is literally practically done. So this angle, this angle, and I want this color. The angle inside the triangle is 52 degrees. That's it. The problem solving's over. All these questions are pretty much the same from here on out. Just be careful with angle of depression. I say this semester after semester, class after class. I really hope one day I'm proven wrong when I say someone's going to do it and someone in here is going to do it. They're going to take the test and say it's 38, right? And it's not. Find that angle right there. From here, now we're going to use the 52 degrees, which, again, this is opposite. This is adjacent. So we got our tangent again, but tangent of 52 equals 80 over x. in addition to being an angle of depression, this equation isn't quite the same as the last one. I mean, it's going to require an additional step. This was one step. We multiplied by 72. We were done. Calculator time. What two steps do we need to do here? But kind of marry them quickly. Well, we're going to multiply both sides by x. Cool. Now it's out of the denominator. But then our second step is to divide it by tan 52. So if you can recognize that, instead of making this a minute long, just kind of do it in one step. Multiply by x and divide by tangent 52. And there's your exact answer. $80 on top of tan 52 is about 62.5. Feet there. Okay. Angle of depression. Number one thing pointed out, too many students will accidentally use the 38. And that'll be partial credit, but I want to see you get full credit on this question. Right? Make sure you're using the 52 degrees. And how do we find that? You're always going to have a 90-degree angle. It's not like anything fancy. It's always this part and this part are going to make it 90 degrees. So, right. Last one out of here. I don't know how to draw a lighthouse. I'm just going to do this. There's the lighthouse. This is like on some island. And so here's the water, apparently. And here's a ship. And here's a plane. That's a weird plane. If I look straight out, I don't look up or down, that's 0. When I look up to the plane, reading this again, the angle of elevation is 22 degrees. Most important thing, the 22 is made with the horizontal right here. So this aspect of it right here, 22 degrees. Boop. And when I look down to the boat, uh, 42 degrees. This right here is 42. I don't see any right triangles yet, but I definitely have my picture drawn. I guess there's one other thing I do want to note. From here to the ground, I'm on a lighthouse that is 254 feet. All right, sketch a diagram. Boom. Find the distance of the ship from the lighthouse. So we want this distance right here. I'm going to highlight that for us. The distance from the ship to the lighthouse. We're looking for the base of that triangle. So I'm going to use my diagram and just draw this. That's 254. And that's X. Okay. Not in the triangle. So remind us, you're always going to get a right angle there. 90 minus 42, 48. Tangents get a lot of love today. But this is opposite. That's adjacent. So we're going to use tangent again. It's not always tangent, just happens to be that right now. Tangent of 48 is opposite over adjacent. All right, this is a one-stepper, meaning just multiply by 254, toss it in a calculator, and you'd be good. To the nearest whole value, 282. And I still think I used feet here. Yep. Find the plane's height above the water. And we're done with this section. I'll highlight it here. So again, if I looked straight ahead, that would be 0. I'm looking up at a plane. Ooh, interesting question. Find the plane's height above the water. I'm going to draw the right triangle. Clean that up a tiny bit. This is ultimately what we're going to focus in on. I can find this. Is this the height above the water? It's super close. Out of 5 points on a test, you'd get 4. What do we have to do once we get that answer? Add the 254. And there's the little bit of problem solving in addition to everything else that was going on here, right? And you have something like this in the homework. And very well, test question 2, right? So this is a good one to review. As you're going through your homework, really think about it. Okay, let's just speed this up. Guys, you guys sound like you know. We're still going to have to find this side. Just remember, that's not our final answer. We have to add the 254 to it. So looking over here, I'll just sketch it. Oh, stop with the highlighter, bro. This is 22. I'm missing another side. Or am I? Man, this question's just loaded with problem solving. What are you thinking? Oh my gosh. We take our answer from before, the 282, and that's the same distance as the base of the triangle. Another layer of problem solving in here. Okay, cool. So if you missed it, you need to pay attention. Part A, boom, right there. Now, that's what we found, which is the same as the base of the blue triangle. So we're going to use 282 right here. I'll call this y since I already used the variable x in this problem, just so it's clear for you guys. We will say that the tangent of 22 is y over 282 multiplied by 282. So I already have this number in my calculator. I'm just going to say times tan 22. So about 114. And the plane is 368 feet above the water. Interesting question, which is why I wanted to share it with you. As I said, definitely a question that you'll have enough warm-up, easy ones where it's just one thing. But when you put both of them together, definitely requires you to work carefully. So I won't run in circles here. This is being recorded. I double check, triple check that it's recorded. So if you need to watch this later, you can come back to it. All right. Hopefully the highlighting of the triangles helps so you can see. And you're basically doing one problem, taking that answer, putting it into the second problem. And lastly, for the third or fourth time, don't forget to add the height that you're looking at. So in this case, you're already 254 feet in the sky. That takes care of angle elevations and depressions. Would have got out of it in a few lessons. Pythagorean theorem, know how to name opposite and adjacent, know SOHCAHTOA, know these two right triangles, even though it kind of feels weird. It'll start coming together in just a minute, but yeah, that's that. And angle of elevation, depression, word problems. Now, moving onwards. More big boy, big girl trigonometry stuff, not taught in like a geometry course. And I've asked a few times who's already had like a more formal trig course and who hasn't, and we're kind of 50-50 in the class. So what we do in this course is more than just the geometry, but not quite a full trig course. This is titled Basic Identities. And so an identity is basically just an equivalent expression. I mean, it kind of makes sense. An identity, what do we associate identity with outside of math? Ourselves. Like, I have an identity. It's not quite the same, but for instance, here's like something we would never really do, but 2 is the same as 1 plus 1. That's an identity. Just means anywhere you see 2 in mathematics, you could replace it with 1 plus 1. Normally, we don't do that. We usually take 1 plus 1 and call it 2. But if you really wanted to, everywhere you saw a 2 in a textbook, replace it with a 1 plus 1, you could do that. That's it. That's the idea of an identity. It's just like, hey, it's something that you're equal to. Whoop-de-doo. Oops. Here are 3 reciprocal identities. That's what they're called. The cosecant, which is abbreviated as CSC theta. What is it equal to? One over sine theta. In other words, flip the sine value. We'll apply it in just another minute. The second of 3 identities is called the secant. It is abbreviated SEC. And you are allowed to replace it with 1 over cosine. So again, that was my connection here. If you saw 2, you could replace it with 1 plus 1. It wouldn't be efficient, but you could. Well, it turns out in more complicated things, maybe in this course, sometimes in calculus, you're going to want to, you see this, you're like, just know it's this. That's the idea. Again, all we're going to do here is flip the cosine value. And lastly, cotangent abbreviated COT. I know this is strange to believe, but it's actually 1 over tangent. That's it. Together, SOHCAHTOA, along with these 3 identities, make up what is called the 6 trig functions. There's never going to be 7, so that's a good news. It's not like, is there more coming? No, there's 6 and only 6 in all of mathematics. Sine, cosine, tangent, and their reciprocals. Here's a little helpful shortcut. Sine starts with S. Its reciprocal starts with C. Cosine starts with C. Its reciprocal starts with S. You don't need a shortcut for remembering this one, right? Just kind of things to recognize. All right, now you can, not that you want to hear this, but if I had noticed that before vacation, I wanted to give you a little homework, but I couldn't find anything that just used sine, cosine, and tangent. But this is like a homework question right off the bat. Similar to what we did last class, but using this triangle below, find the 6 trig functions. 100% a test question and probably 90% a final exam question. So this is like a must know. Let's find the missing side first. Good old Pythagoras says a squared plus b squared equals c squared. Most important thing, c is the hypotenuse, the biggest side right there, opposite the 90. Doesn't matter what we call a and b, so I'll say a squared plus 24 squared equals 25 squared. I'm going to subtract 24 squared, and I'm going to take a square root of that. I know I'm writing this in a very strange way. I'm just trying to use my calculator less. I could have used a calculator right here. I didn't. I subtracted 24 squared on both sides. I could use a calculator right here. I didn't. I just took the square root of that ugliness. And now I'll use my calculator. Square root of 25 squared minus 24 squared. And I get 7. Once we have all 3 parts of our triangle, we'll start with what we know, SOHCAHTOA. This is opposite of theta. This is adjacent 2 theta. And that's our hypotenuse. Sine of theta, opposite over hypotenuse. Cosine of theta, adjacent over hypotenuse. Tangent of theta, opposite over adjacent. Three more to go. Good way to remember it. Sine starts with S. Its reciprocal starts with C, called the cosecant. Cosecant theta. And what did I say up there? You literally just flip this. 25 on top of 7. Easy. Cosine starts with C. Its reciprocal starts with S, the secant. Literally flip the number value. Tangent's reciprocal is cotangent. And there's your final answer, the 6 trig functions. Cool. Not super exciting, but it is what it is. Yeah, that's it. SOHCAHTOA, reciprocal, 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 just means to flip. It does also mean this. All right, I could show you how that actually works out. But it's just not worth the squeeze. I just would put it in a calculator and show that you're going to get this fraction anyways. Why I bring these up? Well, because that's truly what these are. And like I said, if we ever want to change this, not just number values, but we might say, I don't like that. Like, I just don't like those symbols. Even though that's a fraction, sine and cosine become very, very friendly to work with. So I'll let that go. All right. Another collection of identities is not called the Pythagorean theorem, although they're proved with the Pythagorean theorem. They're called the Pythagorean identities. If you had trig, does anyone remember the most famous one, the most important one? Bless you. Bless you. Don't do it again. The most important Pythagorean identity is right here. Sine squared plus cosine squared is 1. It is used so more than those reciprocals, although I would say those are probably second. This one right here is like the golden identity. And you'll see it in calculus. You'll need to use it in calculus. And if you do take a Calc 2, you definitely use it. I mean, this is like a big one. Definitely the biggest. Quick note on the exponent. If you've never seen this before, if you've seen it before, you're used to it. If you haven't, it's just the way it's written. So that's why I'm telling you. A quick note on the exponent. You put the exponent on the trig function, not over here. Reason being, like historically, it caused confusion. So mathematicians way back in the day knew sine squared plus cosine squared equals 1, but when they started putting the exponent on like this angle, like suppose it was 30 degrees, they, like as they were writing letters back to each other, because they didn't text and call and stuff, because they couldn't, but it was like, oh, they want me to take sine of 30 squared, so they want 30 times 30, and it's like, no, that's not what I meant. So just a little historical there, and it's just survived through the ages, so it is what it is. Another Pythagorean identity is 1 plus cotangent squared equals cosecant squared. And the third is tangent squared plus 1 equals secant squared. Now, how are these used? We did a question similar to this before our spring break. We're going to look at it under a new microscope, under a new set of lenses. If sine of theta is root 7/3, state all the remaining trig values. Now, I'm going to propose 2 solutions because I think knowing 2 ways of doing a math question just makes you stronger. One method that we did last class, or last time we were together, anyone remember? What's that? So how would we get started on a question like this?
We know what sine means.
We know what sine means. Cool. So one way is called a right triangle approach. I'm not going to finish it this way because I'll tell you why in a minute, all right? So you literally say, all right, let's draw a right triangle. Kind of like this question up here. And we know what sine means, or no matter, I could have given cosine or tangent. We know what it means. It means opposite and hypotenuse. So we would have called this 3. First of all, we got to put a 90-degree angle in. We have to put our theta in, and then opposite theta would be root 7. And this is why I'm not going to finish it, because now it's like the question right above it. And if you like this method, please, you don't have to detour from it. You really don't have to detour from it. Find the missing side, find the remaining things, done. An identity approach Doesn't require drawing a triangle. It just requires you knowing sine squared plus cosine squared equals 1, and I'll show you how it finishes out. So it's like, yo, I just want to focus on this, right? We could continue down that path, but I want to make sure you understand this is a different way of thinking about the same question. We're going to take our sine value that was given to us and substitute it in right here. Root 7 over 3. Now I could put this in a calculator, but it would take more time. What's root 7 times itself? What's 3 times itself? 7/9. What am I going to do to both sides? Subtract 7/9. I could put this in a calculator. You can too. But I'm going to just try to grow your brain, or like your brain's already strong, but bro, this is 1 and I'm going to take away 7/9. 1 is also 2 over 2, 3 over 3, 4 over 4. It's also 9 out of 9, isn't it? And that's a cool way of thinking about it because I don't need my calculator and I do get quicker at it. 9 out of 9 minus 7 over 9 is 2/9. And then we're going to take a square root of both sides. And I'll just write it because this isn't immediately obvious. But when I take the square root of that fraction, that's not a perfect square. So we're going to leave it square root of 2. The square root of 9 simplifies to 3. Knowing that sine theta is root 7 over 3, I can find cosine theta. By the way, can we just check it? I am super curious. I know it's going to work out. We would find this missing side over here. I'll speed it up just with one color. Root 7 squared plus b squared equals 3 squared. We'd have 7 plus b squared equals 9. We'd subtract 7, we'd get 2. We take a square root and we get root 2. So this base right here is root 2. And then we'd say, all right, what's the cosine of this angle? Adjacent over hypotenuse, root 2 over 3. Same answer, okay? All right, I'm actually gonna omit the rest of this for time's sake, but I will tell you how we would finish it. If I have sine, what else do I almost have for free? It's reciprocal, cosecant. Its reciprocal would be roots 3 on top of root 7. True or false? Did I say that wrong? All right, let me fix it. Let me do it because my brain can't apparently function. So this was given to us. Cosecant is 3 over root 7. And once we found cosine, we basically get this for free. So just for time's sake, I'm not going to do this. How would I find tangent? Well, I have secant, so I'd have to just kind of go through the identity method of this again. Or, since I have cosecant, I can find cotangent. So that's how the identities work together. You really only need one trig function to get the rest. both with a triangular approach and an identity approach. Does that kind of make sense? You don't have to love it, but just appreciate that there's two ways of doing this. Okay. Personally, I actually like the right triangle approach, but I have to show you the identity approach. And there's a time and place where the identities become important. Everyone's clear that there are two paths to lead the same answer. Okay. I'm actually trying to sway you this way, but I don't care which path you want to take. Mini conversation over here. And then I think I saw a hand raised. Let me just kind of finish this out. So I'm going to omit tangent in this. See the square root in the denominator? We don't want that answer. Last time, it was right at the end. So if you missed this, it's a quick fix. Square root in the denominator, you're just going to multiply top and bottom by it. And this is going to be called 3 root 7 over 7. You have to answer this in MyLab. Otherwise, while this is a perfect answer, it really is, MyLab does not want the square root in the denominator. So you quickly, boom, boom, multiply top and bottom by it, and it's gone. It's not a huge deal. It's just like a baby step. 3 root 2 over 2. And I mentioned it, it's called rationalizing the denominator. Not that you need to know that, right? You just need to know, don't leave your square roots in the denominator. Alrighty. This is the last set of identities. And then we're going to talk about radian measure. These are called the cofunctions. What does complementary mean in math? Nope. Nope. They add up to 90. All right, all good tries. I appreciate you guys at least sharing out and adding some communication. Complementary means they add to 90. So for instance, someone said the same. Well, here's a pair of angles that are the same and complementary, but it's the only thing. Like 45 and 45 are the same and they add to 90. But so are 30 and 60. Well, those aren't the same, but they're complementary. So is 89 and 1. All of these pairs are complementary. So I don't want to say the same, although you can have the same. Complementary simply means add to 90. If you have a pair of complementary angles, the sine of one of them is equal to the cosine of the other one. I got a shortcut for remembering this too in just a minute. The tangent of one of them is equal to the cotangent of the other. And lastly, the secant is equal to the cosecant. And I wish I could say it's a creative shortcut, but it's actually not a shortcut at all. It literally is the sine of an angle is equal to the complement of sine. The tangent of an angle is equal to its complementary tangent. The secant of an angle is equal to its complementary cosecant. What is all that saying? Here's an angle. Make up any number you want. 89, 45. I don't really care. Where's its complement? Right there. The two of these have to add to 90, don't they? So this angle right here on the top of this triangle is complementary to this. If you don't believe me, again, make up a number. This is 90, maybe that's 20 and 70. Has to be. All right. What I'm saying is the sine of, let's use 20. The sine of 20 is 7 over 25. That ratio, 7 over 25, is also the cosine of 70. The sine and cosine are the same if they're complementary. Tangent of, well, this make-believe 20-degree angle. Tangent would be 7 over 24. Where's the complement? Right here. What's its cotangent? 7 over 24. That's all that rule is saying. If you have a pair of complementary angles, sine is equal to the complementary sine, cosine. Tangent is equal to the complement of tangent, and secant is equal to the complementary of secant, cosecant. In a right triangle, or for acute angles in a right triangle. So we're just saying, bro, not the right angle. The other two angles. I don't think we need a picture for this, but I'm doing it anyways. It's saying like, hey, one of these angles is 4x. The other one of these angles is 3x plus 13. Now, I don't want to deviate from the question. I just want you to understand this is what it's saying. It's saying not the right triangle, but these two other angles. They have to add up to 90. 4x and this add to 90. For the acute angles in the right triangle, sine of 4x equals cosine of 3x plus 13. Got it. What's the number of degrees in the smaller angle? First, we set up an algebraic equation. I got the words right there. 4x plus 3x plus 13 has to be 90. Bang out the algebra. Combine like terms, subtract 13, divide by 7, boom. Type in 11 in my lab. Sorry, wrong. I hate math. Read the question. What's the measure of the smaller angle? Bro, that's not x. That's 4x. So we need to substitute in the 11 right here. This actually is 44 degrees. And subbing in the 11 right there, you'd have 33 plus 13, known as 47 degrees. The smaller angle is 44. Be quiet. I can't do simple arithmetic. Thank you. All kidding aside. 46, thank you. That's a weird looking 6 now too, so. All right, there we go, 46. Thank you. Pretty common question there. And there's a reason to know that too. So biggest takeaway from the identities. First of all, these three. There are 6 trig functions: sine, cosine, tangent, SOHCAHTOA, and the reciprocals. I gave you a shortcut how to remember them. Not given on a test, not given on a formula sheet ever. You need to know those 3. Must be memorized. Know that. This is the reciprocal of that. This is the reciprocal of that. That's the reciprocal of that. Pythagorean identities. Super important. I said the most important identity. Memorize. Will not be given on a test. However, you do not need to memorize those 2. Recognize they exist. Recognize if I ask you to use them. I don't know. We'll see. Probably not even going to. That one, though, we need sine squared plus cosine squared equals 1. Same thing I do in calculus, right? Because there's so many like different trig identities. It's crazy. When we want to apply them, we know that, hey, let's look in a formula sheet for some of this stuff, right? But some of them are so applied all the time that they just need to be committed to memory. So I'm telling you, that's one of them. Cofunctions. I think it's easy enough to memorize, but since it's so easy to memorize, I'll tell you, you don't have to memorize those, all right? So I would tell you, if 2 angles are complementary, those facts are true, right? So what are your must knows into your long-term knowledge? Reciprocals and sine squared plus cosine squared equals 1. Very attainable to do, right? All right, one more thing for tonight. Something called radian measure, and then we'll get our test back. And now that I'm here, I really do remember us, maybe, I don't remember if it was everyone or some of us just kind of talking about this at the very, very end. On Earth, a circle has 360 degrees. And that's such a weird thing to say, on Earth. Like, on Earth? On Earth, the triangle has 3 sides. Like, why all of a sudden you start this phrase with on Earth? But it's because I'm being serious. It's here on Earth, not on the moon and not on Jupiter. Not on Mars, and not on another planet. Unlikely. Maybe. Small chance. What? So fast forward. This isn't like super important, but it's just slightly interesting. I already went through it with, I think, most of us, if not all of us, but I'll say it again. On Earth, a circle has 360 degrees because our ancestors wanted to survive. So they studied the stars and they learned that things kind of repeated themselves. So they kind of, like, I think naturally just think something that goes in like around, I don't know how to say it without saying it, goes around and like repeats itself. They associated with this idea of circle, not triangle, not square, but circle. And our ancient mathematician scientists needed to assign a number for a full time around. And so since they were monitoring the stars and said, oh, every 365 days, it kind of repeats itself, and then whatever other ways they established that, they said a circle is 360, not 5, even though they knew that 365 is an odd number. You try to divide it by 2, it opens up decimals. You try to divide it by 3, it's not done. So long story short, a choice was made, like, even though they knew 365 is what our planet kind of goes around the sun in, They went with 360. So that's it. There's a quick little why. If you ever get on Jeopardy and you get $1 million, remember why. And that was the question. Again, this is probably too much to write, but you can paraphrase it if you need. So building the story, what is a more universal way, whether I'm on Jupiter or the moon, or if I'm an alien from another planet? One thing I'm always going to have is my feet. No matter what planet I'm on. And that's something I can count. I don't need to watch the stars. And if I walk in a circular manner, I'll just leave what I have here. A longer circle whose radius is 4, I can form a lot of different angles. Imagine a circle of radius 4. You don't have to imagine it that hard. It's right there. And here's me in my starting position. And I put one foot in front of the another. 1, 2, 3, 4. I take the same length of the radius along the circle. That's the connection. The radius is 4. I know the radius is 4. I'm going to walk 4 steps on this circle then. And right in the middle is an angle. It's called a central angle. On Jupiter and another planet, what we would call that is 1 radian. Literally from the base word of radius, you walked the same length of a radius. If this was 13, Taylor Swift's favorite number, we'd have a bigger circle, but I still would be right here in this position because it would just be a bigger circle. Imagine 13 would be out to here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Even just quickly estimating it, maybe a little better than that, but it'd literally be in the same position. It would be 1 radian. Bless you. Similarly, imagine a radius of 4, but I took not 8 steps, but I did 2 groups of radius. 1, 2, 3, 4, 5, 6, 7, 8. This angle right here is called 2 radians. And this is the vibe. Radius of 4. If I went 4, 8, 12. If I did 3 groups of the radius, 3 radians. Radius. Oh, that's what we call it, 3 radians. So I need you to do some mathematics for me right now. Really big, important mathematics. Write an equation that is always true relating S, R, and theta. Meaning, how can you put these three numbers together using an equation that if I use the same setup, it would make that equation true. And if I did over here, it'd make that equation true. What equation can you write?
Radius times theta
Radius times theta equals
equals
arc length. 4 times 3 is 12. 4 times 2 is 8. 4 times 1 is 4. Bingo. Radius times theta equals arc length. Damn you. In other words, r times theta equals s. Thinks that's exactly what was said. But just so it's clear, boom. So if I want to write a formula for theta, what do I need to do to both sides of this equation? Divide by radius. And that's what a radian measure is. You can look it up on Wikipedia, a textbook, or anything. You take whatever arc length you have, you divide it by the radius of the circle, and that's called the radian measure of the angle. I'll stop there, even though I'm not quite done with my conversation on radians. But you have enough to, if you're going to get started on your homework, which I strongly encourage, you can do the one titled like angle of elevation and depression, as well as I think it's called right triangle trig, both of those. There are 2 more on there, and there'll be another one after the next lesson. So here's the thing. I made smaller homework assignments. I don't want you to be like, oh my God, I have 5 things. It's not like there's 40. There's like, some are, I think one's like 10, one's 8. So it's more focused. It's like, boom, this part of the lesson, here's a set of homework questions for it. This part of the lesson, this set of the homework. So when you log in there, if you're not logging in before next class and you're putting it off till Sunday night and you see 4 to 5 or 6 things, and we'll see what is there. Well, yeah, it's still going to be a lot, but in terms of quantity, it should be about the same overall. It's just broken up differently. All right, I'll see you on Wednesday. I'll pass back your tests. If you want to quickly talk about it, I have like 10 or 15 minutes. I plan to take that time. You can look at it, and then I'll definitely devote some time Wednesday to discussing it. But until then, you can kind of peek at it ahead of time. Hila, Krista. I feel like I forgot everyone's name over break. Amelia. Boom. Aiden. Who's Aiden? Aiden. No, Aiden. Sloan, not here. Carlos. Tyler. Neelis. James. Ella. Bradley. Emily. Ella, right? Justin. Kevin. Michael. Zach, Alex. I know Alex. Yeah, I was just like, you just answered the question. Kate, Brian, Guadalupe, Megan, Aiden. All right, just really quick because I know you're going to look at it. I was grading initially some of yours, so some of you're seeing like a couple things crossed out. I apologize. Like if you're like, oh, you crossed out numbers here and there, because I gave a similar test to my other pre-cal class that I talk about, but I was using their answer guide at first to yours, and I'm like, what is going on? And that's why I was like, oh boy. So if you give it a look skis, all right, the points are there. If you think I made a mistake, I'm going to talk through each one. But if you're like, wait, you crossed it out, then you marked it right, then you crossed it out. Figure out the right answer. Make sure I gave you the points. I'm confident I did. And at the end of the day, if you add up all your numerators, all the top values, that should be the number you see first. And then you add up all the bottom ones. There's only 96 points, not 100, because I ended up dropping one. So I added 4 to both the top and the bottom. That was a scale. And that was the number circled, your average, which, so I already put a scale on this. And then I think I scaled them even more into your actual grade book. So I'll talk about exactly how I scaled it. But I guarantee this number is not the number you see in the grade book. It's even higher than that. So, all right. Yeah, I scaled them even a little bit more. I'll go through all of that after. But the number in the grade book is your test score, obviously. Yeah, it's not going down. Not counted.